We are going to multiply this equation, the numerator and the denominator, by sine of x. So we're just going to say this equals, and I'll put in red what I'm multiplying. So I'm going to multiply that first thing by sine of x over sine of x. And I'm going to stick everything else the same. I'm just going to change this sine of x over 1, because realistically that's what we have. We have sine of x over 1. All right, plus, and I didn't change anything with the cosine squared x over sine of x. All right, we do that multiplication. And we're going to see we have sine squared x over sine of x plus cosine squared x all over sine of x. Well, now we have a common denominator, sine of x. So that's going to give me sine squared x plus cosine squared x all over sine of x. And anytime we see sine squared plus cosine squared, we should be like, oh, this is a good problem, because I probably did something right. It's going to equal 1. Whoop, where'd that line come from? So that is going to equal, let's come down here and finish that problem. So that's just going to equal, well, sine squared plus cosine squared is 1 over sine of x. Can I simplify that even further? Alex, you're shaking your head yes. What can I turn that into? I can change it to cosecant. Okay. That'd be a tough sell to change that to cosine. So this is going to be cosecant x. I got rid of all the numbers. I have one cosecant. I have to know I'm done. I have to know. I can't get any simple. There's no fractions. I'm done. So the hardest thing about these problems is sometimes realizing when you're done and when you're not done. Okay, so there's no questions on the homework, so let's just go on to the... I said there's no questions on the homework. But I said there's none. Okay, Rosie, you got a question?
95.
95. I believe that is the one that is incorrect. Did you look at the answer guide?
Yeah.
Because the answer... Yes, the answer guide would not make sense. So, where are you guys? You guys are 6.1. 6.1 C2 6. Where is yours? Oh well, we'll just use this one. Hopefully I don't already have it filled in. We'll see. Okay, we don't. Okay, 95 is wrong. I didn't write it correctly because I'm transferring over what's in the book by hand, typing it in. So it's missing a whole chunk right here. If you look at the answer guide, it actually had 1 over sine cubed x plus like cosine something something. So I miswrote it. A good thing about that is I do give you the page number on here, so if you think something's a little fishy, go ahead and look in your book and make sure I wrote it down correctly, or just put a little note saying, just in case I check your homework, hey, this one didn't look right. It didn't match up what was in the answer guide. Something's wrong. So in fact, the only way to actually solve this one is to say, well, what the inverse or the reciprocal of sine would be cosecant. So that's all you'd have to do for that one, is cosecant cubed x, because it's missing a whole chunk of the problem. But yes, the answer guide wouldn't make any sense with that problem. So that one was wrong in the notes. So if you looked at the answer guide, you should have been like, that's not right. All right, other questions? Yeah?
91.
91. 91. So there's a couple ways to do 91. What I'm going to look at is the fact that, well, I have sine squared minus cosine squared. We know that sine squared plus cosine squared equals 1. Can I just say it's close enough? Is that okay? And just say it equals 1, kind of? No. So we can't do anything with this top thing. So the next thing I'm going to look at is, hey, I got cosine here, I got cosine here. If only I could write sine squared in terms of cosine. And is that possible? can I rewrite sine squared alpha as something else, some other identity, or some other trig thing that just involves cosine? Is it possible? Yeah.
1 minus cosine squared.
1 minus, yeah. So if I look at let me take a picture of mine real quick. So if I look at my identity sheet, and this is a good trick to know, that's why we're doing these problems, is because the more times you do these, the more times you realize what kind of tricks you can do. Well, if sine squared plus cosine squared x equals 1, I can move this cosine to the other side, and sine squared is going to equal 1 minus cosine squared. So that tells us anytime I have cosine squared or sine squared, I can always convert them to something involving the other. So if I have sine squared, I can convert it to something that says cosine squared. And if I just have cosine squared, I can convert it to something that says sine squared. So that's going to be your tip on, that guy. This guy is that I have so many cosines that I want to change this to something that's in terms of cosines. So we're going to say this is going to equal 1 minus cosine squared alpha minus cosine squared alpha. So this little section is the one I changed. All over 1 minus 2 cosine squared alpha. Well, I have two of these guys. So it's like having negative x minus x would be negative 2x. This is just going to become negative 2 cosine squared alpha. So we have 1 minus cosine squared, oh, I forgot to put the 2. 1 minus 2 cosine squared alpha all over 1 minus 2 cosine squared alpha. Well, that just equals 1. Got something on top? It's that same thing on the bottom. Just turns into 1. Make sense? Yeah. So that's one of the tricks is basically if you see one, if you can't do anything to the top, and you see one trig function appearing more than the other, try to change that other trig function into something that returns of the other. So you can see that cosine is kind of creeping up here. Just let it happen and make this cosine. It was almost that answer. I gave you a hint. So at some point you should have came up with a 2 over sine squared x that was on the bottom there, which could have been simplified even further to being 2 cosecant squared x. So in fact, that is your final answer. I just gave this as like a checkpoint. Did you get that?
I didn't see it.
Oh, did you get that answer?
Yes.
Yeah, I did. I could have put like an arrow or something like that up here, but I meant to tell you, but I forgot. So you can blame that on me. I'm terrible at everything. All right, other questions? Yeah.
Go over how we got that?
Over how we got this one?
Yes.
Okay, so the first thing we need to do is we need to get rid of this negative sign here. So we just got to think, do I have to pull it out front, or does it just disappear? It disappears. Okay. Oh, okay. So we'd have 1 over 1 plus cosine x. And I'm going to leave, actually, I'm going to leave some space in front of it. So I'd have 1 over 1 plus cosine x plus, I'm going to leave a huge space, 1 over 1 minus cosine x. Because there's no way to combine these unless they have the exact same denominator. So what you're going to do is you're going to take the denominator from the other fraction and multiply the numerator. So this is going to be 1 minus cosine x over 1 minus cosine x, and this is going to be times 1 plus cosine x over 1 plus cosine x. Alright, so that's just going to equal 1 minus cosine x over that 1 minus cosine x times 1 plus cosine x. And in fact, let's shortcut this really quick, so I'd have 1 plus cosine x when I push it together. And then it's just eliminating these. When you do this, it's going to turn into sine squared x. And then you're going to see it turns into what we have down there.
Okay.
Can you kind of see that? We did the problems like this. This is difference of squares, so it's 1 minus cosine squared x. Is that good, or do you want to see it?
Yeah, that's good.
Okay. All right, other questions? Really? Gone once? Going twice? All right, I want to go over one. I want to go over 93. I'm going to go over 93 twice. So pay attention whether you got it or you didn't get it. I'm going to go through it two completely different ways to show you that sometimes there's multiple ways to solve it and come up with the exact same answer. So the first way I'm going to go through it is the one that they have in the answer guide. If you looked in the answer guide, they did this method. So what they did is they factored out a tangent out of the numerator. So they rewrote this as tangent x times tangent squared x minus secant squared x all over cotangent, well, it's just negative cotangent x because I pulled that negative out front. Okay, so I just took out a tangent, and if I would distribute this back in, it would turn back into this. Now we'd realize that tangent squared x minus secant squared x, well, I have all those squared, so I'm probably dealing with one of those Pythagorean identities. So I would just have to, if I was on the test, didn't I take a picture of it somewhere? Didn't I already have a picture of our identity sheet somewhere? Did we see a picture of our identity sheet? Did it disappear? So if I was taking this test, I'd already have these written on the top of my test. All right, I'd already have all three of these written on the top of my test. I might have other ones that I get messed up with. I might have these even odds, or especially this cosine secant one, because that one, the negative sign just disappears. I would have all of that on my test, and so I would go, well, I have a bunch of squareds. I have tan squared minus secant squared, so I look at the one that has tan squared and secant squared. Hey, it's this guy. It's this guy. Now I just want to manipulate this so it says tan squared minus secant squared. And how that might look is, whoop, that's too much. Let's give myself a little workspace here. Well, my tangent is positive. My tangent's positive on this side, so I want to get the secant over here. So I'd subtract both sides by secant, which would be 1 plus tangent squared minus secant squared equals 0. Move the 1 to the other side, and I'd have tangent squared minus secant squared equals a negative 1. So as long as I have these written up there, I can manipulate them later on. I don't need to write down all the possible variations. All right, I can manipulate and say, well, I know this is here, I can work it somehow. So that tells me that tan squared minus secant squared equals a negative 1. So this is just going to equal, well, that's a negative 1, so I'll have negative tangent x over negative cotangent x here. But I can rewrite negative cotangent, well, first of all, it's going to turn to a positive. So we're going to have tan x, bless you, over cotangent is just 1 over tangent x. Using keep, change, flip, or multiply by the reciprocal, I keep tangent, change that to a multiplication sign, flip this so this tangent comes up here, and our final answer would be tangent squared x. Who did it that way? Who didn't do it that way? Did you change your secant right away?
I don't know what exactly. I did it
Oh, okay.
very wrong way.
Did you get the answer?
No.
No, okay. So pick one of these two ways. I have it written down so you can review it. Because the whole point of these is to do one over and over and over. Because there's only so many of these problems that work out. So there's always a chance you're going to see this exact problem again. You might see this exact problem again. You might see this exact problem again. All right? Especially because I pull problems out of our homework and I put those right smack dab on the test. All right? That way you can't say we didn't go over it because a lot of times it's already in, you already did it once. There is a completely different way to do this one. and this is a very valid method and will work across a lot of problems, is to say, I have tangent, I have tangent, I have cotangent. I'm saying tangent a lot, and all of a sudden I say secant. This is the odd man out. This guy doesn't belong. There's something wrong with him. Alright, so what I'm going to say to myself is, how can I change secant squared to turn it into a tangent? Alright, just like we did over here, I changed that sine squared into something that has cosine. I can do the same thing here. I'm going to change that secant squared. I'm going to change that secant squared. So I'm going to write everything else the same. I'll have tangent cubed x. How can I rewrite secant squared in terms of tangent? Yeah. Tangent squared plus 1. Perfect. So I could change that to tangent squared plus 1 times tangent. I'm going to cut out the x's right now just to save some time. On the bottom, I still have that negative cotangent x. Will I do my distributing? We'll have to distribute kind of two different things. Because I have to distribute this tangent, and I also have to distribute this negative sign. So we're going to know everything in here is negative. So that is going to equal tangent cubed x minus tangent cubed, I guess x, plus tangent x. In fact, that shouldn't be a plus, it should actually be a minus, because that negative sign should have been distributed to both things as well. Alright, and that whole thing is going to be over negative cotangent x. Well, tangent cubed minus tangent cubed is 0. Minus tan x is going to be negative tangent x over negative cotangent x. Didn't we already have that on the other one? Same exact. I'm not going to finish it because we already finished it last time, but it gets to the exact same point. So my point is there's multiple ways to do these, so don't just say the book way is the only way to do it. That, oh, my way is wrong, I'm going to erase it and do the book way. This way, in my mind, is somewhat, well, in their own right, this one can be just as easy or easier than the other method because it is already set up for you in the book that it's tan x. I don't have to manipulate any of the Pythagorean identities. I can just plug this in, and then I'm purely dealing with tangent across the board. I don't have secant hanging around. Okay? So multiple ways to do things. All right, questions on either two methods that I used? No? Okay, then let's get into today's lesson. I should go by pretty quick because it's stuff we've already seen, actually. It's just one new idea. Okay, we're talking about verifying identities. We're going to add to this list tomorrow. We're actually not going to verify any identities today in our homework. We're just going to be simplifying stuff and matching stuff up. But just the basics of verifying identities is I need to prove that both sides of the equation are equal. And I need to prove it without plugging in numbers and without doing, like, you know how you take the square root of both sides? I can't do anything to both sides at the same time. So the big two steps you need to do is you need to choose a side to start with. Alright? A lot of these you only have to work on one side the entire time. Some of them you have to work on both sides. We'll talk more about that tomorrow. But we just pick a side. And the side we're going to pick is surprisingly the hardest side. The one that looks the biggest and the most complicated. Because with trig identities, it's easier to work your way down than trying to build up to the other one. So you're going to pick the most complicated side and work your way down and hope it equals that other side. Then you're going to simplify that side until it reduces to the other side. Use trig identities, algebra, whatever you need to do it. So an example of that would be verifying the identity 1 plus secant x sine x tan x equals secant squared x. If I say verify an identity, I'm not going to trick you. Alright? I'm not going to give you one that, it's not actually an identity. Gotcha. Gotcha, Mike. Good work. Way to spend an hour on that. I gotcha. No, it will be an identity. So if you can't figure out an answer, look at the answer guide. Try to get some help. Alright. So what I do on identities, just because I am not a super neat person, I take a line, maybe I take a line, it's not letting me. I actually tell myself I have two sides I'm going to work. I have two sides of this equation. Nothing from here is going to go over here. Nothing from here is going to go over here. So this blocks that. So that way, when I focus on a side, I'm only doing work on that side on this. All right, keeps everything organized. If you're one of those people that do a bunch of notes all off to the side, it's going to be a good chance you're going to mess stuff up. So try to keep your sides separated. Our number one rule is to find the most complicated side. Pretty sure that's this guy. This guy's got a lot going on. This is just secant squared. So I'm just going to focus on this guy. All right, I'm not even worried about the secant squared, honestly. Because with these, if you simplify a side, generally it'll come down to this side, regardless of how you do it. So I'm just focused on this side. I'm not even worried about this secant squared thing. I'm looking at, I have secant. First of all, how can I rewrite secant? Yeah. 1 over cosine. Awesome. I already have sine. How can I rewrite tangent? Yeah.
Sine over cosine.
Sine over, that's a lot of sine and cosines, right?
Yeah.
That seems like a good way to go with this one. So I'm just going to rewrite all three of these in terms of sine and cosine. So I'm just focusing on the left-hand side. So we're going to have 1 plus, well, we said secant is 1 over cosine times, well, sine, since we have a fraction, you don't have to, but a lot of times it's nice just to say, well, that's sine over 1. And then our tangent is going to be sine of x over cosine of x. Like I said, I'm not worried about the other side. I'm hoping that everything's just going to work out. All right, you can almost cover that up if it's so small. It's just going to work out. All right, so we're going to have 1 plus 1 times sine is sine squared. Sine squared x on top. Cosine x times 1 times cosine x is cosine squared x. Still haven't done anything to the other side. That's why I keep it separated. Can I rewrite sine squared over cosine squared to anything? Yeah.
It'd be tan squared.
It'd be tan squared. So we have 1 plus tangent squared x. Still not worried about the other side because I haven't finished simplifying. Can I rewrite 1 plus tangent squared as something else? Remember, use your identity sheets if you get stuck. Yeah.
Secant squared x.
Oh, boom. 1 plus tangent squared x. We can rewrite a secant squared x. Well, that's what I wanted it to equal to. Boom, boom, boom. I'm done. Obviously, if this side was more complicated, we may have to solve both sides at the same time. But just seeing that this was secant squared x, I just trusted the fact that if I simplified this, it would come out to either the correct answer or something I would be able to say, oh, if I just flip this one thing, then I have secant squared x, all right? So a lot of these, don't try to look at the whole picture. Don't say, oh man, how am I going to get this to secant? I want to keep the secant because the answer... Don't try to force it into this box. Just kind of, ease back. Just do what you do. Simplify, and everything should work out. All right? Don't try to force anything in a box, and don't try to do it in your head. Don't try to do every single step in your head, because that's when it turns into you on the test sitting there for 10 minutes looking at one problem. All right? These problems require you to write stuff. So even if you're stuck, say if I'm stuck on this one, I have no idea how I get to there, I'm going to tell myself, hey, do something. Change tangent. Change secant. Do something. And if you do something and you get stuck, it just means try something else. All right? But you should, on every single problem, have work down that at least you're changing stuff. All right, that's my advice to these. Yeah?
Sure, we can't just plug some reasoning into there and solve and see if they equal each other.
Oh, you could absolutely do that. The problem is you'd have to prove that every single radian works for that.
Okay, I suppose.
So if you could plug in every possible number in the world in these, then you could do that method. Unfortunately,
We don't have time.
I don't have the time for that. So let's just do it this way. These are just multiplying, so nothing new. All right. We could think of this as just being 1 plus x times 1 minus x, which is a difference of squares, which if you remember difference of squares, this is just going to be 1 squared minus tangent squared, which is just be 1 minus tangent squared. I'm going to show every step, but it's always nice to see this and know the answer rather than doing work. But I am going to do all the work because I am the one teaching it. Alright, so you can either use FOIL, distributing. I'm just going to distribute. I'm going to distribute that 1 to that 1, which equals 1, I'm pretty sure. I could be wrong. 1 times negative tangent is just going to be negative tan x. I distributed my 1 fully, so I'm going to distribute my tangent to that 1. Tangent x times 1 is a positive tangent x. And finally, I'm going to distribute that tangent to that other tangent, which is going to give me negative tangent squared x. But we'll see these cancel out, and it's just what I said. It's 1 squared, which is 1, minus tangent squared x. It's a difference of squares. If I have 2 sine alpha plus 1 squared, we do have to remember that squared is the whole thing, so it's 2 sine alpha plus 1 times 2 sine alpha plus 1. But we're going to follow the exact same thing we did on the other one. We're just going to distribute this 2 to that 2 sine. Well, 2 times 2 is 4 sine squared alpha. I have 2 sine times that 1, which is just going to give me plus 2 sine alpha. I do that 1. I have another 2 sine alpha. And finally, I distribute that 1 to the 1, which would just give me 1. And we are just going to have 4 sine squared alpha plus 4 sine alpha plus 1. So sine alpha works just like x. If I'd have 2x plus 1 squared, I'd come up with the exact same answer just with x's instead of sine alpha. In fact, sometimes replacing things with x and y and variables we've seen before can sometimes make these problems easier. So if you're someone that struggles, because we're going to factor next. Factoring can be sometimes hard when you get a bunch of sines and you have a bunch of cosines. So sometimes it's nice to just think about this. Well, secant squared minus tan squared could be thought of as just x squared minus y squared. Well, that's just a difference of squares, which we can rewrite as x minus y times x plus y. So we can do the exact same thing with secant squared minus tangent squared. It's a difference of squares. So that's going to give me secant x minus tangent x times secant x plus tangent x. Same thing if I have sine squared plus sine minus 2. If you're good at this, you don't have to convert it to x's or y's. I just want you to think about it in those terms. It can make factoring a little easier, because sometimes factoring can be tough on its own. So I'm thinking of this as being x squared plus x minus 2, and it's the exact same problem. So when I factor, I'm just going to use the guess and check kind of method, where I know my first term has to be x times x to give me x squared. The only pair that multiplies together to give me negative 2 would be 2 and 1. When I add 2 to 1, I need to come up with a positive 1. So that means one of them needs to be negative. Which one needs to be negative? Liz? The 1. And the 2 has to be positive. So the same thing's going to happen up here. Same exact process and exactly the same answer. To get sine squared, my first thing has to be sine squared. Sine squared. Put that in there. I need a 2 at the end, so 2 times 1 is 2. Once again, I need a positive by the 2 and a negative by the 1. That's all you got to do, factor and distribute. Works the exact same thing if you have x's as if you have sine squared beta. Questions on any of those? All right, that's the bulk of what you're going to be doing today for homework. You do have a matching section, and then the rest is just multiplying, factoring. All right, things that we're going to need to be able to do to verify information. All right.